All right, so what you were asked to do today was this nearpod. So we're going to go through the nearpod, and it tells me, so a monomial. We've all heard of polynomials, but I don't know that we've ever talked about a monomial. Mono means one. So anytime you hear mono, that means one, okay, that prefix. So the examples it gives us are 5x, 2xy squared, 7, 10x to the fifth, y to the fourth. Okay, a polynomial, which is what we've been using, is just a mixture of multiple monomials. So it says a sum or difference of monomials, literally meaning it's adding or subtracting monomials. So 5x is a monomial, but when I add it to 4x cubed, it becomes a binomial, which means 2. And then when I subtract minus 9, that becomes a trinomial. So this right here is a trinomial. This one would be a quadrinomial. And this one is a binomial. 4 plus x is a binomial. Standard form, we should know this from when we did quadratics. Ax squared plus bx plus c. But now, because we're getting higher order, meaning that now we have cubed, which is to the third power, we have quartic, which is to the fourth power, and quintic, which is to the fifth power, we still need to keep them in order. So if we're given 4x squared minus 3 plus 5x plus x to the fifth, we can't use that right now. We have to put it in standard form. And we'll see why throughout this unit. But we want it to be in standard form. So now it's going to go in descending order, which just means it's going to go from the highest to the lowest. So x to the fifth, then we see x squared, then we see x, and then we see 3. Okay? So this was the worksheet that you were asked to fill in, and we'll come back to this in a separate video, okay? So when you went through here, hopefully you were taking some notes. Again, polynomial, it tells you exactly what it is. I just went over that. Then it gives us the different names, which I also just went over. A monomial means one term. Binomial means two terms. This is binomials and trinomials is what we're most familiar with so far. So a binomial was when we were doing multiplication, we'd multiply both of these by each other, and we'd end up with something that looked like a trinomial. Or we'd factor a trinomial, and it looked like two sets of binomials. So then it gives us like a real life situation. So like a monocycle, otherwise known as a unicycle, a bicycle, a tricycle. Okay, we're familiar with those. A quad, so like a four-wheeler, right? We're familiar with those prefixes. So then it tells us the degree. The degree of a polynomial with no variable is 0. Why is that? Well, the number 21, there is no variable there at all. So if there's no variable there at all, that means it has to be a degree of 0. Anything to the 0 power, try this in your calculator or on Desmos, anything to the 0 power is 1. So if I have x to the 0 power, it's not there anymore, it's just 1. So then it tells us when we talk about degree, we're not just talking about any exponent that we see. Here I see an exponent of 4, an exponent of 2, and then the x has an exponent of 1. But we're not talking about that. We're talking about the degree, not just the exponent. Degree is the exponent that is the highest. So here between 4, 2, and 1, my degree would be 4. And then down here I have 2, I have 0, I have 3, I have 6. Well, the highest one would be 6. And I'd rewrite this one in order to give me it in standard form. And here you go. Here are the different names of the functions by their degree. So you guys should all be familiar with constant, linear, and quadratic at this point. Linear, literally, it looks like a line when you draw it. Quadratic, we should know at this point, looks like a parabola, so like a U-shaped graph. So if something is to the third power, we call it cubic. You have heard that word as well. And now you guys need to get familiar with, if something is to the fourth power, it's called quartic. If something is to the fifth power, it's called quintic. After the fifth power, we just say to the sixth power, to the seventh power, to the eighth power. It's technically fine to still say to the first power, to the second power, to the third power, to the fourth power, to the fifth power. But these are the names that they're associated with. So I can call this a linear function. I can call this one quadratic, so on and so forth. Then it asked me to put this example in standard form. So again, I see a 6, I see a 3, I see a 0, I see a 2. So I need to go 6, 3, 2, and then 0. So my answer will be x to the 6th power plus 4x cubed plus 3x squared minus 7. And I just keep the sign that it currently has. So like, if I'm like, well, how do I know if I need to add or subtract the 3x squared? Well, it's already positive. There's no negative number in front of it. So that's why we end up getting this here. X to the 6th plus 4x to the 3rd plus 3x squared minus 7. All right, so hopefully you got that first part. That is all about what the names of the polynomials are. Now we're moving on to something that is also familiar. We did this when we did vertexes. Here we should see that this is the peak. This is a max. Why? Because it's at the top. Then if I come over here, that's a valley. That's the bottom, okay? That is a minimum. So it's asking me what is the coordinate here. And it's already written here for me. It's 1, 4. Now it's going to ask me, actually, let's go back real quick. Let's pay attention to the fact that not only is it a peak of a function, it changes from increasing to decreasing. So what that means is, as I'm going up, I'm obviously increasing in the y value. Up. I go from 0 to 4. But after my peak, I start to come down again. So that's what it means when it says increasing to decreasing. And then same thing is going to happen over here. I'm going from this, which is decreasing, and I get to this point, which is going to be 3 for my x and 0 for my y. And then if I keep going up, it's increasing. So that one is changing from decreasing to increasing. And these are what we call U-turns. U-turns you should be slightly familiar with from real life. You know that if you're in a car and somebody makes a U-turn, it's going to look something like this, like, oh, crap, I forgot something at home, let me turn around, that kind of thing. That's a U-turn, okay? So this graph actually has 2 U-turns. And I can tell that it has 2 U-turns based on what I literally see with my eyes. I see 1 peak, 1 valley, so together that is 2 U-turns. And now here's an example of a lot of different graphs. How many U-turns do each of these have? Well, A is just, the graph at A is just a straight line. There aren't any U-turns. That's like I went from point A to point B without making any turns, okay? For B, that's similar to what we just saw on the last slide. I go up, and then I come down and go back up. So that means it has 2 U-turns. If we look at graph C, that again is another linear function. It is a straight line. So it has no U-turns. Then if I look at D, I'm just going to count the humps. Like if you think of it like a camel, but you got to count the valleys in the camel's humps as well. So I see 1, 2, 3, 4. Because I have 1, 2 peaks or maxes and 1, 2 valleys or mins. Okay? So D would have 4 U-turns. E is our friend, good old parabola that we're familiar with. It obviously has 1 U-turn. I go from increasing, and then after the peak, I go to decreasing. So it has only had 1 U-turn. F, hopefully it's not too hard to see, has 1 minimum here. And then right around here, there's a peak, a slight peak. And then right around here, there's a slight minimum. So this F actually has 1, 2, 3 U-turns. Okay? And it'll be pretty easy to spot U-turns after a little practice. This is another example of 1 U-turn. My graph is going from decreasing, and after that, it starts to increase again. So that is 1 U-turn. So those are U-turns. So U-turns, you literally just look at the graph, and that is how you determine how many U-turns are in the graph. If you're looking at a graph, you count where it changes from increasing to decreasing, or you just count what I call the humps, and that tells you how many U-turns there are. But that's only if you have a graph. We'll come back to U-turns in a little while on our worksheet. Now we want to talk about leading coefficient. We have heard the word coefficient multiple times. When we talk about A and C and we're factoring and all of that, those are coefficients. But now when we say leading coefficient, well, what is that? Well, here it tells me leading is the first number. Coefficient, it tells me, is the number in front of the variable. So therefore, it says the leading coefficient is the number in front of the variable with the highest exponent. So again, it's not just any of these numbers. I have to look for the highest exponent first. So remember, the exponent is the number that's on top of the variable. So I have an exponent of 3, an exponent of 2, an exponent of 1, which we don't usually write, but I know it's 1 there. And then here, because this is a constant, the exponent would be 0 on that variable. So therefore, 3 is the highest number. Therefore, it's my leading degree. So that means that 4x cubed would be my leading coefficient. 4x cubed is the leading coefficient because it is on the leading term, 4x cubed. Constants we should be able to recognize. Constants have not changed. They always are the ones that remain the same. They do not have a variable attached to them. And the constant is always our y-intercept. So if you ever want to know y-intercept or constant, you always look for the one that does not have a variable next to it. All right, and that is it. All right, so hopefully you understood me going through this a little bit better than you did on your own. And check out the next video to see how you should have filled out that worksheet.